Okay, this is the first in a series of random homework problems for Calc II. We'll be talking about integration by parts. And just to remind you, the integration by parts formula is the antiderivative of u dv is equal to uv minus the antiderivative of v du. And the idea here is you choose u and you choose dv out of the problem, and then you take the derivative of u, you take the antiderivative of dv, and then you plug those in over here on the right hand side of the formula. So I picked out two problems from the homework, both of which have little interesting tricks to them. The first one, this is the homework from page 490, so the first one is number 19, and it is one of those problems that involves ln of x, and pretty much anytime you have ln of x in your problem, you're going to be doing integration by parts. So what we need to do with this one before we start the problem is to adjust what it looks like, because you can't do a substitution like this, or let me put it this way, it's confusing to look at it this way because you might be tempted to pull x squared out for your u, all right, or your dv, all right, and that's not really what you have. What you really have is x to the negative 2 ln of x dx. All right, so once we have it set up like this, remember I mentioned in class, anytime you have ln of x in your antiderivative and you're doing by parts, that has to be your u. So we let u be ln of x, which makes du 1 over x dx. Then we choose dv to be whatever's left in the problem, and that is x to the minus 2 dx. So now we take the antiderivative of dv, and the antiderivative of this is just a power rule, so add 1 to the exponent and divide, so that's going to be minus 1 x to the minus 1. Right? And then we come back over here and we put this together in the formula. So we do u times v, so that's ln of x times negative 1 x to the negative 1. All right, that's a little sloppy, but I'll fix it. Minus the antiderivative of v, minus 1 x to the minus 1 du, which is 1 over x dx. All right, so we get here, let's fix all this up here. Minus 1, so minus ln of x, and then x to the minus 1 becomes 1 over x. Minus, all right, now I've got minus, minus, so that becomes plus. I'm not going to take the antiderivative yet. Now this right here, right, what does this become right here? All right, remember this, I'll just kind of tuck it in up here, is 1 over x. All right, so I get 1 over x times 1 over x, which is 1 over x squared. So that's x to the minus 2 dx. All right. So minus ln of x over x plus, and now I have to take the antiderivative of this, which is basically the same thing I got there. All right, minus 1 x to the minus 1 plus c. All right, so I can now fix this up here, minus ln of x over x, and then plus minus, so that becomes minus 1 over x plus c. Now if you go to check this on your TI-89 calculator, one of the things that they're going to do is to factor out the negative 1 and combine the two fractions. So you may see something that looks like this. Okay, and that would be your final answer. All right, so that's the first problem. The only part you had to remember with this was to change 1 over x squared to x to the minus 2 before you started the problem. The next problem, which is number 24 from the same homework set, is a little more involved. All right, when you look at this, there is no straightforward integration by parts substitution to do, because I can't let e to the negative x, ae to the negative square root of x be my dv, because that would be the problem I'm trying to take the antiderivative of, and I can't do that. And if I let it be u, then it's a chain rule, and I'm going to end up with a much more complicated function that is only going to make things worse. So the trick with this one is you actually have to make a substitution in advance of doing the u substitution portion of the problem. So what you want to do is you want to make a substitution for the square root of x. Now I don't want to use u because I want to use that, I want to refer to that for my use for my integration by parts. So I'm just going to call it w. So we'll make a w substitution for the square root of x. All right, and now I have to take the derivative of that, so I want to look at it as a power function. All right, so dw is going to be 1/2 x to the negative 1/2. Remember, for the derivative you subtract from the exponent, dx. All right, now we still have a problem because there's no way for me to substitute this back up here, right? I don't have an x to the negative 1/2 in here to make the substitution for dw. So I'm going to show you a neat little trick, something you can do. All right, I need to move this whole term over to the other side. All right, and I know it's going to be mixing variables, but we'll fix that. So 1/2 comes over as 2. And then x to the negative 1/2 is really 1 over x to the 1/2, so I bring it over here as x to the 1/2 dw, and now that's equal to dx. Now I can't substitute this back in for dx because I'm mixing my variables, but I can come back up here and I can solve this equation for x. So if w is the square root of x, then w squared is x, and now I can take this value for x and put it back in here. So this will be 2, and I'll do it in steps. W squared to the 1/2 dw, and then I can simplify this to w to the 1 to squared to the 1/2 is just w, dw equals dx. And now I can come back up here and I can substitute all of this back in. All right, so I'm going to have dx is going to be 2w dw. So I can take the 2 outside the antiderivative sign, w, and I want to leave some room. I'll put the dw in at the end. E to the negative square root of x. So square root of x is w, so that's e to the negative w dw. All right, now this problem with a variable swap is exactly one that we did in class. So let's do it again. All right, so now I need to do my by parts substitution. So my by parts substitution, let me make a little squiggly there, get that out of the way. All right, we let u be w, right? The thing that's going to get less complicated when I take its derivative, and in fact, it completely goes away. Whoop. W, not x. All right, and then I let dv be what I have left, which is e to the negative w dw. I really want that to be an x. Take the antiderivative of both sides of this. This becomes negative e to the negative w. And then I can do the by parts formula. So u times v, so it's going to be negative w e to the negative w minus the antiderivative. Now remember, this is all being multiplied by 2, so we have to put that out there. Times the antiderivative of uv v du. Okay, so negative e to the negative w dw. Alright, again, that's all being multiplied by 2. Alright, so I'm going to leave the 2 in front. We'll deal with that at the end. Okay, minus WE to the minus W. And then minus minus becomes plus. The antiderivative of e to the minus w is again minus e to the minus w. Close all those, plus c. Alright, so let's fix this up. One more fix up before we substitute back. Alright, minus we to the minus w, so now plus a minus, so that's minus e to the minus w plus c. Alright, now before I go any further, I want to clean up my algebra in here, right? I've got a minus that I can factor out, and I can make that minus 2. I can also factor out an e to the minus w. It's easier to see if I do it at this step. Alright, so then I'm left with w plus 1 plus c. Alright, so now I can substitute back in for w. So here's my w. Alright, so this is minus 2 e to the minus square root of x times the square root of x plus 1 plus c. Alright, and if you check your answer on your TI-89 calculator, this is exactly what you get. Alright, and that's it for this random homework problems.